This is Mr. Martin. These are video notes for Pre-Calculus Advanced. This is the fourth video for parabolas. We're looking at the third example in the We Do section. So we'll do this together in the video. And we want to analyze the equation. So when we see this word analyze, what we're basically going to be doing is finding all the important parts. We're going to put it in standard form. We're going to find the vertex, the focus, the directrix, the axis of symmetry. We're going to find the length of the lattice rectum, and we're going to find the coordinates of the lattice rectum. So anytime you see this analyzed, like number 4, which you're going to do on your own, you want to make sure you find all 6 of those things, including the standard form. So let's start with the standard form. We can see we've got x squared, so we're going to leave that on the left. So we have x squared plus 4x. We're going to have to complete the square, so I'm going to leave a space there, plus something. When I move that to the other side, I get positive 4y, and whatever we add on the left, we'll have to add on the right. So we're going to have to take half of 4, so that's 2, and square it. Add that on the other side as well. This becomes a perfect square trinomial, so it's x plus 2 squared is equal to 4y plus 4. And one more step, we'll factor out that 4 on the right. X plus 2 squared is equal to 4 times y plus 1. So here's my standard form. Alright, the next thing that I'm going to do is find p. So we see x is squared and we see p is positive, so we know this is going to open up. And I know that the 4p is equal to 4. This whole value here is equal to 4p, and we use that to solve for p, so p is going to equal 1. Now, once I get to this spot, I'm going to graph what I have so far. Okay? So, and I know one more piece of information. So I've got my vertex, which I can get from my standard form. So h is going to be -2, and k is going to be -1. So -2, -1. Make a little sketch over here. So -2, -1, and p is positive and x is squared, so I know it's going to open up. Okay, and once I have this, I know that p is 1, so I'm going to go 1 unit up to locate my focus, and I'm just going to pull that point right off the graph so I can see that I'm at -2, 0. I went up from -1, 1 unit. And I know my directrix, so this is my distance p right here. And I'm going to go p units down. So p is 1, so I'm going to go 1 unit down over here to get my directrix. Remember, the directrix is a line, so you need the equation of a line. Directrix, it goes through the y-axis, so it's going to be y equals, and it goes through at -2, so y equals -2. And we need our axis of symmetry. So that's the line that goes through the focus and the vertex. It divides our parabola into 2 equal halves, in this case a left and a right. And I can see that it goes through x at -2. So we have x equals -2, just coincidence with these -2's here. And then we need the length of the lattice rectum, and we know that that's 4p. My 4p is right here in the standard form, so that's easy. That's just going to be 4. And then we want the coordinates of the endpoints of the lattice rectum. So I'm going to draw this in over here. Remember, it goes through the focus and connects the opposite sides of the parabola. So this is going to be one coordinate, and this is going to be the other coordinate. So since I know the length of this is 4, I know I have to go 2 units to the left. If I go 2 units to the left, I was at -2, so I'm going to be at -4, 0. And then if I go 2 units to the right, my graph's a little bit off here, but if I'm at -2 and I go 2 units to the right, I'm going to be at 0. comma, 0. Okay, so there you have it. We've got the standard form: vertex, focus, directrix, axis symmetry, length of the lattice rectum, and the coordinates of the endpoints. So as always, if you have any questions, make sure you ask. Feel free to pause and rewind as needed, and we'll see you in the next video.